Okay, we're going to look at graphing cubic equations. And similar to when we were graphing things like sine and cosine, the crux of this is knowing the shape of your graph. So we know the shape of linear graphs, a straight line, the shape of quadratic graphs, that U shape or the N shape. And we have a kind of a sideways S shape in general for cubic functions. Now there's two different ways that the S can go. It can start down low, come up and go like this, or it can go the other way, start up high, go down and then back up and finish coming down. And how do you know which general shape it will have? Well, when the leading coefficient is positive, so if you have a plus x cubed, it will finish pointing upwards. And if you have a minus x cubed, the leading coefficient is negative, it'll finish pointing down. So it finishes pointing up when it's positive at the start, excuse me, and it finishes pointing down when it's negative at the start. Other things that you want to look for when you're asked to plot the graph of a cubic equation is you'll need the shape, you'll need the y-intercept, and the y-intercept will be the constant, the last term with no x in it. That's the y-intercept, where it crosses the y-axis. And in general, you probably want to find the roots. So the roots are where it crosses. It crosses the x-axis. Later, when we do calculus, so a little question mark next to this, you don't always need this, the turning points. The turning points. Now, if you find those four things and you have them plotted, you can use the shape to sketch your graph quite quickly, and you'll be able to get full marks for the question. Now, you can, of course, just do an input-output table, listing your values here and plotting them and working with those. So it depends on the information that you're given. So let's look at the first example that we have here. We're asked to plot this graph here in the domain -4, x between -4 and 2. So because they've given us a domain like this, we might even use an input-output table for this. It might be the quickest way to do it. But let's start with what we know. We know the shape. I'll write it here because I want to use most of the room for the graph. We know that the shape of the graph will be like this because we have a plus x cubed. We know that our y-intercept is going to be at y equals -6. Okay, so that's where it's going to cross the y-axis. What about the rest? Well, why don't we use a quick input-output table here? So we could solve this, finding the roots using algebra, but it might be just as quick to do an input-output table. So the inputs are my domain. X equal to -4, -3, -2, 1, 0, 1, and 2. And my outputs are my y values. They're what I get when I sub into x cubed plus 4x squared plus x minus 6. So I'm going to generate my couples from this. The nice thing about the calculator is that we can just put in the pattern. So I'm going to have x cubed, we'll start with the first one there, -4 cubed plus 4x, 4 bracket -4 squared plus x plus a -4. I'm putting the plus minus in there because later I'll be replacing the x values with different x values and then take 6. So I've typed in my function and I get that minus 10 is my output for that first value. And then I just use my arrows to come back and change all of those minus 4s to minus 3s. Minus 3s and a minus 3 here. And I get 0. So that's going to be a root. It's going to be a place where it'll cross the x-axis. Come back again. And I'm using my negative 2s. Negative 2, and we get 0. So we have a second root. Then minus 1. Negative 1, minus 1. And we get minus 4. Keep going. 0 I know is going to be minus 6, so I don't have to bother filling that in. 1. Now this time it's a plus 1, so I must remember to delete my minus sign. And this one here, delete the minus sign, we get 0. So we have our 3 roots actually came up. They're not always at integers, but they are in this case. And 2 is the last value that I want to fill in. And we get 20. So we know that we need to sketch this graph. The y values are going to go between minus 10 and 20, and the x values are going to go between minus 4 and 2. So if I'm going from minus 10 to 20, that's 30 boxes in total that I need. Let's see how many I have. 3, 6, 9, 12, 15, 18, 21, 22 boxes there, so I don't have 30. We'll go up in 2s. I'll use 5 boxes to represent a 10. And we need to go from minus 4 to 2. Minus 4. Minus 3, minus 2, minus 1, 0, 1, 2. That's my x-axis. And we're going 2, 3, 4, 5, up as far as 20, 10. Oh, I've drawn it in the wrong place. I should have gone through 0, not through minus 1. Sorry for shaking that. Let's move this over. Now, my y-axis goes up as far as 20, 10, minus 10. I can fill in minus 20 as well. So let's plot the relevant points. We know that we have 2, 4, 6. That's going to be my y-intercept. It's at 6. And I've got my roots, minus 3, 0, minus 2, 0, and 1, 0. That's actually enough because I know the shape is going to be finishing coming up here. Sorry, that should have been a minus 6. I knew that was looking weird. Minus 2, minus 6. So there we go, minus 6. It doesn't go through at 6, it goes through at minus 6. Okay, so I know the shape, but let's put in the other points as well. Minus 4, minus 10, down here. Minus 1, minus 4. There's minus 4. And 220 up there. And like with all graphs, so we don't really know how far up it's going to go, but that's okay for the sketch that we're doing. Carefully go over it. to make the shape that we expect to see. A kind of sideways S shape ending, pointing up. Okay, so that's the graph. And you can go over it with a highlighter if you want, but feel like if the points are done in pen, the rest can be done in pencil with no problems whatsoever. And it's good practice always to label our diagram, label our actual graph. So that's f of x equal to x cubed plus 4x squared plus x minus 6. And that's the full graph. Okay, thank you.